Hey guys, I'm going to go over the independence portion of it. Here's the first question. It says, suppose you roll two fair six-sided dice, one blue and one orange. Are the events sum is 5 and orange die shows 3 independent? Justify your answer. Okay, so now in order for us to show independence, we need to go ahead and show this. This is the formula for independence. So so we have the sum is 5 given orange is 3, okay? So that's should be equal to the probability the sum is 5, okay? All right, so if these two are equal, then it's independent, okay? So let's go ahead and figure this one out. So the probability that the sum is 5, okay? So we have a sample space. Let's go ahead and figure out how many combinations you can get of 5, okay? So you can get 2, 3, okay? And then you can also get 3, 2, 1, 4, and 4, 1. So these are the only types of ways in which you can have the sum of 5. And this is out of 36 because there's 36 types combinations in which you can get these types of pairs, okay? So it's going to be 4 out of 36 combinations, okay? All right, we want to know if that's equal to this portion here. So I'm going to put a question mark here because I'm not sure if they're equal to yet. And if you think about it, we're going to go ahead and do this on the side. We want to know out of all the times that your orange is 3, okay? So I'm going to give you all the combinations where you can have a 3. So let's say this first spot is orange. So 3, 1, 3, 2, 3, 3, 3, 3, and 3, 4, 3, 5, and 3, 6, okay? So now we have 1, 2, 3, 4, 5, 6, but we got to make sure that the sum is 5. So the only one that has the sum is 5 is this one here. So out of all the 6 that I have, only one of them is 5, okay? So are these two equal to each other? And the answer is no, because this is equal to 1/9. So that means they're not independent. Okay? All right. Now the next question says, suppose you roll two fair six-sided dice, one blue and one orange. Are the events sum is 9 and orange shows 5 independent? So same thing here. Very similar to this one. Okay, we're going to go ahead and do the probability that the sum is 9 given that orange is 5. And we want to know if that is equal to the probability that the sum is 9. Okay, so we can start off with this one first. So first let's list out all the possibilities that we can get 9. Okay, so we can get 4 and 5, 5 and 4, 3 and 6, 6 and 3, and I'm pretty sure that's all the combinations. Okay, so here there should only be 4 out of 36, just like it was last time, which is equal to 1/9. 1/9. Okay. Now this portion here, we're gonna do the same thing. So we're gonna list out all the ones where we can have 5. So 5 and 1, 5 and 2, 5 and 3, 5, 4, 5, 5, and 5, 6. Okay. So out of all these, how many are 9s? So it's only this one here. Okay. So out of the 6 that I have, so out of the 6, only one of them is 9. So once again, 1/9 is not equal to 1/6. So we're going to say not independent. Okay? All right. Let's go ahead and go over the next one. Okay, so this one's kind of lengthy. But it says you work at Tony's Calzones restaurant. You have the following information about the 7 calzones in the oven. 3 of the 7 have whole wheat, have wheat crust. 2 of the 3 wheat crust calzones have pepperoni. Of the remaining 4 calzones, 2 have pepperoni. Choose pizza at random from the oven. And then here it says make a two-way table to model the chance process. Okay. All right. So now here we're going to try to make a two-way table on this portion here. Okay. So here's our two-way table. Sorry about that, the light went out. All right, so here we have wheat, and here we have not wheat. So I'm going to put NW. Okay, and then here we have pepperoni, and here that it's not pepperoni, NP. Okay, all right, so that's telling us that 3 of the 7 have wheat crust. Okay, so here on the bottom I'm going to put 3 of the entire 7 have wheat crust. Okay, what else does it say? It says 2 of the 3 wheat crusts are calzones. So here I'm going to put 2. Okay, and then it also says of the remaining 4 calzones, 2 have pepperoni. So here are the remaining calzones. So how many have pepperoni? It's 2 have pepperoni. Okay, so now we can kind of start filling in this table here. We know that the total here should be 3, so we can put a 1 here. And we know here the total should be 4 because we add them up. And then here the remaining portion is 3. Here is 4. So in order for this to add up here, this needs to be a 2. Okay? All right, so now that's our two-way table. So it says here, are the events getting a wheat calzone and getting a calzone with pepperoni independent? So here, let's go ahead and figure out with our formula. So here we have the probability that you get a wheat calzone given that you have pepperoni on it. Is that equal to the probability that you have wheat? Okay, so the probability that you have wheat is right here. So the probability you have wheat is 3 out of the 7. So 3 out of the 7 calzones that are made, that's your probability of getting wheat. And of all the ones that have pepperoni, so this line here, out of all the ones that have pepperoni, what are the chances of you getting wheat? Okay, so our sample space for the pepperoni is 4. So of the 4 that we can choose from that have pepperoni, how many are wheat? It's 2. Okay, so which is equal to 1/2. So that means these are not equal to. So that means they're not independent. Okay. All right, let's try this last one here. So it says here, if you add an 1/8 calzone to the oven, the calzone has wheat crust with only cheese. Now, are the events getting a wheat crust calzone and getting a calzone with pepperoni independent? So now we go back to this table, and we can actually make some modifications here. So they're going to add another pepperoni, another calzone that does not have pepperoni. Okay. So it's going to be another wheat with cheese. Okay. So that means that it is going to be wheat and does not have pepperoni. So it's going to be a 2 here. We're going to change that to a 2. So that ends up changing this to a 4. Okay. Which in turn changes this to a 4 as well and changes the total to an 8. Okay. So now let's double check to see if that's true. So we're going to double check this portion that we have done on B. We're going to recheck it using different numbers, okay? So we want to know if the probability of getting wheat, given that you have pepperoni, is equal to the probability of getting wheat, okay? So the probability of getting wheat now is 4 out of 8, okay? So 4 out of 8, which is equal to 1/2, okay? And the probability of getting wheat, given you have pepperoni, so the pepperoni is here, okay? This line, so that you have 4 options to choose from, and we want to make sure they're wheat, so it's 2. Now, are these equal? And the answer is yes, so that means they're independent. Okay?